Hello friend, today we are going to discuss an important topic which is known as salt hydrolysis. Now first of all we want to understand what is the meaning of salt hydrolysis. Simply it means hydrolysis of salt in water. And whenever a salt undergoes hydrolysis reaction with water, it produces acid and base. This salt hydrolysis reaction is just reverse of neutralization reaction. To understand this, let us consider a general example of salt, which is Ba. When it undergoes hydrolysis reaction with water, it forms Ha and BH, means acid and base. Salt hydrolysis are of two types, one of which is known as cationic hydrolysis, when the cation part of the salt is taking part in hydrolysis reaction, then it is said to be as cationic hydrolysis. Whenever cationic hydrolysis is taking place, solution become acidic in nature. To understand this, let us consider an example of cation B plus, which can be obtained from the salt that we have already taken Ba. B plus, when interacts with the water, it forms BH and H plus ion, and due to this H plus ion, the nature of the solution becomes acidic. Now similarly, when the anion part of the salt is taking part in hydrolysis reaction, then it is said to be as anionic hydrolysis, and due to the anionic hydrolysis, the solution become basic. To understand this, let us consider an example of anion, that is A minus. When it undergoes hydrolysis reaction with water, it forms Ha and OH minus ion, and this OH minus ion is responsible for the basic nature of the solution. Now here we want to discuss another important topic, that is expression for the hydrolysis constant, degree of hydrolysis, and pH of the solution of salt of weak, acid and strong base. So first of all we want to find out the expression for hydrolysis constant. Since the nature of the salt, that is, the salt is formed due to the combination of weak acid and strong base, so whenever salt of weak acid and strong base undergoes hydrolysis reaction, the nature of the solution becomes basic because the nature of the base is strong in nature. And whenever the solution becomes basic, an ion part of the salt is taking part in hydrolysis reaction, so it is an example of anionic hydrolysis. Let us consider salt hydrolysis Ba plus water reversible Ha plus BOH. Since the nature of hydrolysis reaction is anionic hydrolysis, so A minus plus water reversible Ha plus OH minus ion. Applying law of mass action in the equation, we can get the value of hydrolysis constant Kh, and which is equal to the product of concentration of Ha, product of concentration of Ha and OH minus ion divided by concentration of A minus ion. Now let us consider dissociation of weak acid. Ha undergoes dissociation to form H plus and A minus ion. By applying the law of mass action, we can find out the value of dissociation constant Ka, which is concentration of H plus and A minus ion divided by concentration of Ha. Now, by the value of ionic product of water, we have ionic product of water is defined as product of concentration of H plus and OH minus ion. Now what we need to do, multiply equation 1 and 2 and divide by equation 3, that is Kh into K by Kw. By putting the value of Kh, K and Kw and solving, we can get Kh into K by Kw is equal to 1, and therefore Kh is equal to Kw by Ka. This equation number 4 represents the equation for the hydrolysis constant. for the salt of weak acid and strong base. Now we want to find out expression for degree of hydrolysis. Now consider anionic hydrolysis. Initially concentration of anion is C and that of concentration of Ha and OH minus ion is equal to 0. When equilibrium is achieved, concentration of A minus ion will be C1 minus H, that of Ha CH, and concentration of OH minus is also CH. Now again, by applying the law of mass action, we can get the expression for Kh, which is the ratio of product of concentration of Ha and OH minus and that of A minus ion. Concentration of OH minus ion is already given, that is CH, and therefore putting all these value, concentration of Ha, concentration of OH minus and concentration of A minus, we get Kh is equal to Ch square divided by 1 minus H. Now for weak acid, 1 minus H approaches unity. Therefore Kh equal to Ch square and H is equal to under root Kh by C. This is the equation number 5. Now putting the value of hydrolysis constant, we can get the expression for degree of hydrolysis. H is equal to root under Kw by K into C, since Kh is equal to Kw by K. This is the expression for degree of hydrolysis for the salt of weak acid and strong base. Now the next part of the question is to find out the expression for pH value. Again we consider anionic hydrolysis that we have already discussed in earlier part. By the ionic product of water, we have Kw is equal to concentration of H plus and concentration of OH minus. Therefore concentration of H plus equal to Kw by concentration of OH minus. Concentration of OH minus is already find out, that is Ch. Now putting the value of concentration of OH minus in the given equation, we have concentration of H plus equal to Kw by concentration of Ch. Now putting the value of degree of hydrolysis in the given equation, we get concentration of H plus equal to Kw by C to the power Kw by K into C, which is the expression for degree of hydrolysis. Now we can solve this equation in such way: concentration of H plus equal to Kw by C into root under K into C by Kw. Now taking square both sides, the equation changes in such way, and on solving this equation we get concentration of H plus square equal to Kw into K by C. Therefore concentration of H plus equal to root under Kw into K by C. Now taking negative log both sides, we get minus log H plus equal to minus log Kw into K by C, and root is changes as a half, 1 by 2. Now we know that when the concentration of H plus ion is expressed in negative log, it is said to be as pH. Therefore minus log H plus is considered as pH, and then minus 1 by 2 log Kw plus log K minus log C. Thank you for watching.